All right, this is 2019 response test questions over here. So we're gonna start, okay, no calculated section first, okay. I think this one, okay, we did it before, but we're gonna try one more times, okay, 2000, because we did it 2022, 2021, and 2020. 2020, we didn't do that. I think there's no questions, something like that. So anyway, this one is 2019, okay? So, no calculated sections. Okay, now, number 3. After you finish number 6, we go back to number 1 and 2, okay? Calculate sections. All right, this number 3, it is continuous. Yeah, when you take a look at the graph of f, that's continuous. There's no discontinuity, okay? All right, the interval is given negative 6 to 5. They are all continuous. There's no gap, no jump, okay? The figure above shows a portion of a graph of f consisting of 2 line segment, okay? We have one line segment here, another here, and this is the quarter, right? Yeah, that's the center over here. They said this is the center. 5 and 3 is the center. It is known that point 3 and 3 negative 5. When x is 3, this up here, this point is 3 minus square root 5, okay? That's the height of it. A little less than 1, okay? Because well, square root 5 is 2.2275, something like that. Okay, all right. Okay, the first question A, integral. Okay, we're gonna find the area under this curve between negative 6 and 5. It's given already negative 6 and 5. Okay, here is negative 6, we don't know. Negative 3, negative 4, negative 5, negative 6. Up to all the way up to here. Okay, all the way up here. When you make right area up to 5, that is total area is 6, entire area is 6. Find the value of what? Negative 6 and 2 between over here, this area.
Yeah.
Okay. So the idea is what? The entire area is 7. After you find the area from negative 2 and 5, take up this area from 7, it's going to have this one, right? If this is A, the next one, negative 2, 5 area is B. A plus B is 7, right? If we find the area of this one from negative 2 to 5, A equals what? 7 minus B, right? Now let's find this area. First one over here, this one is 1 and 1. This area is 1 times 1 and divided by 2, 1/2. It's okay using the graph, right? Because the equation is not given, better use a graph. This is a plus 1/2. This is the bottom of here, minus 1/2, right? It's going to be 0. It's okay?
Yeah.
Okay, another. Here and here, also what? Same area, right? Also 0. Up to here, total is still 0. It's okay? And this one, anyway, 1/2 over here. 1/2 times 1, 1/2 times 1, and divided by 2. 1, 2 is 1/4. This is a negative 1/4. This is a positive 1/4. They are congruent triangles. Their area is opposite side, okay? Plus minus 0. Okay, first is a plus minus 0. Here the plus minus 0 up to here. They are all area, sum of area is still 0. After that, we're gonna find this one. This is different, right? This is 1 over here. 1 times 1. This is what? 1 times the height is 2, right? Okay. So how much? 1 times 2 divided by 2 still 1. It's okay? So up to here, 1 plus 2, we got the area is 2, right? So this area goes from negative 6, from negative 2 to 5, okay? We're going to find over here. From negative 2 to 5, f of x dx. Okay? But this is plus minus 0 plus minus, this one is 2. We can use a 2 plus. What is the area of this one? Have to find the area of this square, right? 3 times 3. Okay, the area of this square is 9. Minus quarter area of this quarter of circle. This area is how much? Over here, entire circle is pi r squared is 9 pi. Right? But this 9 pi we can divide it by 4, 9 pi over 4, right? When you take up 9 pi over 4 from 9, this is the area of these sections. That is the total, okay? So 2 plus 9 is 11. And minus still we have 9 pi over 4. We better use this way, right? Because we cannot use the calculator. So you don't have to use the decimal number, okay? Just so you can leave it this way. So 11 minus 9 pi over 4 is the area of this one. Now, we take off from 7, right? Take off this area from 7, isn't it? Entire area from negative 6 to 5. All right? That is 7. This area, you take off from 7, you got what area between over here, right? We don't have we don't have anything, no information. Just so we can find the area, okay? So 7 minus 11 minus 9 pi over 4, right? That's the area of this one. That's the area negative 2, 6 to 2, f of x and dx. Graph is not given, and equation is not given, but still we know, right, the area, right? Okay. So 9 minus 11 is negative 4. Negative 9 pi over 4, positive 9 pi over 4. So better looking 9 pi over 4 minus 4 is better. Yeah. That's the area, okay? The missing part of your integral from negative 6 to negative 2. It's okay? Right, this is fine. Second one is 3 to 5 over here. I'm going to delete this one, too complicated. 3 to 5. Here. You're going to take integral 3 to 5 over here. That's right? Yeah. But this one is f prime x, okay? We got this one. 3 to 5. 2 times 2 is f of x, f prime x dx. Okay, you can separate, okay, with additions. Also what? 3 to the 5 and the 4 is the next one, the 4 dx. You can separate this way. And what is f prime x? Derivative, right? Okay, 3 to 5. But what is the antiderivative? F prime x antiderivative is f of x. That's right? Right. So this one is, we said, what, 2 times antiderivative is x of 5. We take integral from 3 to 5. After that, over here, this is the 4 of x. Antiderivative 4 of x. Take integral 3 and 5, okay? All right, you calculate this one. 2 to the what? 2 is the unit of Francis. F over 5. 5 put in the x. The first term is f over 5. And my second is f over 3. That's the first one. Second one is 4x times 5. 4 times 5 is 20. Minus 4 times 3 is what? 12. That is 8. So now put this number f over 5 and f over 3, okay? F over 5 over here. What happened? 0, isn't it? This is 0. F over 3 is how much? Oh, we don't know, but it's given over here. Just over here, right? F over 3 is what? The height is 3 minus square root 5, okay? This one is minus 3 minus square root 5, okay? Nice. 3 minus square root 5. So this equals to 2. 0 is nothing. Minus in there, but still have inside 3 minus square root of 5. and plus 8. Okay, inside is negative 3 plus square root 5 times 2 there. 2 times negative 3 is negative 6 plus 2 square root 5 and plus 8, right? So 8 minus 6 is 2 plus 2 square root 5. That's the value of this one, okay?
Yeah.
I think it'll be no problem at all, okay? You can do that. The NB. The third question. The function g is given by, we create a new one using the area, okay? Using the area. What is it? We're going to calculate area from negative 2 from here. We're going to calculate the area over here, right? X is what move up to the right over here. Okay? That is X. So FT is same graph, this one. Okay? FT just like, to avoid confusion, just we change the variable, okay? This graph, f of x, we can use f of t, but because we use x is over here as a variable, we switch by x before we change into t, okay? All right, dt over here. Now this is what with respect to x, this is a variable, that is a function of x, okay? There's no more t there. Find the absolute maximum value of g on the interval negative 2 and 5. Absolute maximum. Highest point. We count over here. You can count over here. From 2 over here, 0, right? F over 0 is plus minus 0. You can see that. From negative 2, x equals 0 over here. ft dt 0, isn't it?
Yeah.
Up to x equals 0, that is 0, right?
Yeah.
Okay. After that, over here, 1 up to 1 also 0, right? Minus plus. Maybe you can use up to 1, also 0. Nothing changed. From here, now we got that answer, okay? From here, right there. All the way to a positive area, isn't it? Until 5 over here, right? Okay, they're all positive area. Okay, so you can find over here. When you start from 2, 5, that is what? Absolute maximum, isn't it?
Yeah.
Because we're gonna over here 2 is only this much. We start with this up to here, they are all 0, okay? So from here, this is area. 3 is 3 more. 5 is up more. They're all positive area. So up to 5, they are all maximum value, okay? So what's the area of this one? What is the maximum value? When x equals up to 5, okay?
Yeah.
When we take right x value up to 5, that is the highest numbers, maximum number, okay? The largest area, isn't it? So up to here we know the 0 over here. But just before, this is how much? 1 and 1 over here, right? We got the 2 over here. What is the area of this one? Just before we did, right? 9 minus 9 by, that is 11 over here, right?
Yeah.
Okay, we already got over here. All the area up to the 5, that is the maximum value, okay? So the answer is, what is it? 11 minus 9 pi over 4, okay? When up to x equals 8. I'm sorry, x equals 5, okay? So g over 5, okay? So you can, g over 5 is, when x is 5, that is what? Absolute maximum, okay? The value is 11 minus 9 pi over 4, okay? Are you okay with this?
Yeah.
Okay.
Yeah.
All right, number D. Find this limit value when x close to 1, 10 to the x minus 3 times f prime x over f of x minus r tangent x. First, we can put this number 1 there. Okay, always use 0. Just 0 over 0. If denominator is not 0, you can put in the number. If denominator is 0, a little different. If 0 over 0, there is a limit, but we have to use the L'Hopital's rule. If this is a constant of 0, that is undefined, you have to check right two-side limit. I'm sorry, one-side limit, okay? Now check out, put this number there. 10 to the 1, 10, 3 times f of prime 1 over f of 1 minus arctangent, I mean this symbol, arctangent 1. Is this 0 over 0? What is f prime 1 there? F prime is what? Slope of at x equal 1, right? F prime. Okay, I'm with this one. What's the slope of this one? Oops, what is this? F prime slope is this slope, right?
Yeah.
2 down, 1 right. Okay, 1 right, 2 up. The slope is 2. It's okay? So f prime 1 already 2. This number is 2. So 10 minus 3 times 2 is not 0, okay? 10 minus 3 times 2 is what? 6. That is 4. It is not anymore 0. That's fine. F of 1 is how much? F of 1 high, this y value is 1, right?
Yeah.
Okay. The y coordinate f of 1 is 1. Tangent, arctangent 1 is how much? Arctangent 1 is a pi over 4, isn't it? Right? You understand? Theta equals arctangent 1. Arc means what? Angles. If this is what, you can leave this one first, okay? You can leave it. If you know this pi over 4, you can use it directly, okay? This one. So you can switch to a standard form. Tangent theta equals 1. Tangent theta equals 1 is the opposite over adjacent. There's 1 and 1, that's why 1, right? This is isosceles triangle. That is 45 degree pi over 4, right? So theta equals pi over 4 there. So arctangent 1, arctangent 1 value is always 4 over 5, okay?
Yeah.
Right. Just memorize this, okay? We don't have to use why always go this way. Okay, just what arctangent 1 is pi over 4. Okay, that is the limit value, okay? That is not 0, 0. Denominator is not 0. Just put this number in there. A little simplify. This is a complex fractions. We multiply the common denominator times 4 and times 4. That is better. Looking nice. 4 times 4 is 16. 1 times 4 is 4. Pi over 4 times 4 is pi, right? That is looking nice. Better expression, right? So 16 over pi minus 4 is the answer, okay? That's the limit value. Okay, this limit value, okay, simple, okay? We don't need any L'Hopital's rule, okay?
Okay.
Yeah, that is number 3, okay? How to think? You can do the number 3?
Yeah.
Yeah, we can do that, right? That number 3 is not hard, okay? Okay, now move to number 4 here. We have a cylindrical barrel with diameter 2 feet contains a collected rainwater over here. Yeah, they collected water over here, okay? Diameter 2, the water is now 8 feet. The water drains out through a valve. It's not shown. Okay, I'm gonna make a drain valve over here, okay? Drain out. The rate of change of height of the water in barrel with respect to time is matter dH dt. The rate of change in height is dH dt. This is getting down, move down, right? Reduce, that's why you got the negative sign. Equals negative 1 over 10 h. Negative sign means what? Decreasing, okay? The height is decreasing because the water is drained out, okay? All right, and the volume is given, okay? Because volume equals what? Pi r squared h, we know that, right? The volume of cylinder is pi r squared is the base times height, okay? All right, now we have a question number 8 there. Find the rate of change of volume. That's when you find rate of change of volume. What is that? dB dt, right? With respect to time. That's when you find dB dt, right? When the height of the situation, when the instant, we're gonna find at the instant, at the moment, okay? At moment is what it is. At this times, height is 4. At this moment, okay? We're gonna find the dB dt. Is it okay? But this one is what? dH dt is also function of h. At this time, h You can put this number h in there. You got what dh dt at this time h is 4. It's okay. I'm gonna find out dh dt at h is 4, right?
Yeah.
dh dt is about negative 1 over 10 times square root 4, right? That is 2, isn't it? So negative 2 over 10 equals actually negative 1 over 5. At this times, h equals 4, right?
Yeah.
All right, indicate unit of measure. Okay, yeah, the unit is what is that? This one is the feet is what volume is cubic per second. It's okay? Yeah, that's the rate. Cubic per minute or second. Where is it? Time t, yeah, second, okay? Yeah. This one should be what is that? Feet cube per second, right? That is the rate of change of volume, okay? All right. Okay, now let's find out. First, we're going to find the relation between volume and h. Volume is what is that? I'm going to use the volume. Pi r square h already given over here, okay?
Yeah.
Okay. H is a variable, okay? H is a variable, B is a variable. Is this R is a variable? No, R doesn't change. This R is not variable, okay? This is R equals 1, isn't it? Because the diameter is 2. R equals 1. This is a constant. Put just the number 1 there. Volume actually equals what? Pi R squared 1 pi H. This is the primary equation between volume and height. Now take a derivative with respect to time. dv dt. Pi is a constant, pi times. dh, h is a function of time, dh dt, right? That's it. But at this moment, that's h equals 4, dh dt equals negative 1 over 5. So pi times negative 1 over 5. When? At h equals 4, right?
Yeah.
So when h equals 4, dv dt, now we got the number. dv dt equals negative pi over 5. Cubic feet per seconds. Okay, that is dv dt. Are you okay with this?
Yeah.
Question number A is okay, right? I think that is not hard. Just set up the right equations, right, which is called primary equations. After that, take a derivative with respect to time t. After that, you can get the right related rate. This is we said related rate.
Yeah.
Rate is related. Okay, their connection, right? They have connect each other. That we said related rate. So this is a given. Using this given, you can find the other related rate. Okay. Okay, number B. Number A is okay. When the height is what is 3 feet, now height is changed. It's 3 feet. Is the rate of change of height of water with respect to time increasing or decreasing? Okay.
Yeah.
So when h equals 3 over here, when h equals 3 at this moment, the rate of change, this one, dh dt, we're talking about dh dt. This is the rate of change, not only h. Okay, this amount, this quantity, this amount is increasing. Two choice, increasing or decreasing.
Yeah.
Okay. So increasing, decreasing, how can you check? It's a derivative, right? What is derivative of this one? Second derivative over here, h. Okay, we take derivative of this one more times. dt, d, derivative, this one is what? dh dt, isn't it?
Yeah.
If this is a positive, increasing, okay? If this is a greater than 0, positive, dH dt is increasing. If this was a negative, dH dt, if this is positive, I'm going to write down, dH dt is increasing. Okay, we're not talking about their concavity, right? Actually, H is right. This is a positive, means a concave of at this time H equals 3, right?
Yeah.
Okay? But increase, decrease, it's take a derivative, always, right? It's a derivative again, right?
Yeah.
This is why original dH dt, we're talking about why checking this point, this amount, okay? dH dt. So each derivative means what? Second derivative, it's okay? So second derivative less than 0 means dH dt is increasing. Oh no, I'm sorry. This is increasing. Positive is increasing. This is decreasing, okay? You check it out. So we take a derivative over here, okay? When h equals 3. dH dt is given by the over here. dH and dt equals negative 1 over 10. Square root h is what? H over 1 over 2. You can use this one, okay? Take a derivative of this one again. dt d again. It's okay? Now take a derivative. Negative 1 over 10, but 1 over 2 move to the front. Negative 1 over 20, right? H and minus 1 is negative 1 half. Actually, what is that? Negative 1 over 20 square root h. Isn't it? That is the second derivative. Now we're going to find this something situation at h equal 3 there, okay? Put this number 3 there. When x equal 3, how much? Second derivative, okay? D square h and the dt square second derivative equals how much? Negative 1 over 20 square root 3. It is negative, right? Less than 0 is negative, isn't it? So the second derivative is less than 0. First derivative is what? Decreasing, okay?
Yeah.
So you can explain this one, okay? dH dt is less than 0 since dth over dt square minus 1 over 20 rad 3 is less than 0. Okay? So what is that? dH dt is decreasing, right?
Yeah.
Compare this one. If f of prime x is less than 0, f of x decreasing. Same thing, right? Okay? Derivative is less than 0. Antiderivative is what? Decreasing. Are you okay?
Yeah.
Second derivative is derivative of first derivative. That is less than 0. So first derivative is still decreasing. You have to explain this way, okay? Let me check. Just give me 1 minute, okay?
Yeah.
Oh, I missed something over here. Oh my God, I'm sorry. I forgot to write this. You need to change, right? This is not finally the age with respect to time, okay? I did it wrong. Its derivative is wrong, right? Yeah, that's why. That's why I thought it's weird.
Yeah.
But I couldn't see it. Times t. Take a derivative of first one, h first, okay? Move down, negative 1 over h, h is okay, right? But h is still a function of time, okay? You have to multiply it, what is that? dh dt again, it's okay?
Yeah.
Yeah, that's what I missed. My God. Okay, this is a big mistake. Okay, don't forget this one. Okay, because h is a function of time. Okay, all right. So when h equals 3, we have to find this one. Okay, put this number 3 there. Minus 1 over 2 square root 3. Okay, h equals 3. So we're gonna find the dHdt over here. dHdt over here. Okay, when h equals 3. When h equals 3, dHdt is how much? dHdt equals negative 1 over 10 over square root 3, okay?
Yeah.
That is dHdt at h equals 3, okay? So I'm going to write down at h equals 3, okay? So over here, dHdt is what? Negative again, negative 1 over 10 square root 3, okay? That is a big mistake, but now I correct it, okay? So negative is a positive 20 times 10 is 200 times square root 3 is what? Out. It's okay?
Yeah.
So negative, positive, right? Just before we got negative, but this is actually positive. 1 over 200. That is positive. Okay? So this one is second derivative is positive, first derivative is what? Increase, okay? Increasing is correct. I'm sorry. Okay? Because second derivative, this second derivative is passive, from means the first derivative is increasing, okay? You have to show this one, okay? That is number C, okay? Number C, okay, it need a little, okay, attention, okay?
Yeah.
All right. Number C there. At time t equals 0, at seconds, the height of the water is 5 feet. It was before originally 5 feet, okay?
Yeah.
And use separation variable to find the expression h in terms of t. We're going to solve this differential equation over here. dh dt equals negative 1 over 10 square root h. That is a differential equation, dE. We can say differential equation, dE, okay?
Yeah.
But there is the initial condition there. When t equals 0, h equals 5. Okay, this?
Mm.
Yeah, that is the initial conditions. T equals 0, h equals 5. Now take a derivative. No, take integral, right? Okay. This is separable. We know that, right? Separable.
Yeah.
Only high score, only a separable equation is available, okay? Not anything else. Anything else is very complicated. Okay? There are many homogeneous, okay, and what is that? There are many different ways, okay? But only separable equations in high score. Separable is way as well. Same variable to one side, or the other variable the other side. H variable to the left. I'm going to do this one. So this one is H over here. I'm going to first one, step 1. dH equals to times dt both sides. Negative 1 over 2 square root h times dt. But this is h cannot stay here, right? That's the t. This is the h variable, okay?
Yeah.
So h is all to the move to the left. So that is what square root h. 1 over square root h dh. That is equals to 1 over 10 times dt. That just we said separated. Okay? After that, we take right integral, okay?
Mm.
Okay, inside over here, that is the h is what? The h equals negative 1 half. How can you take integral over here? Antiderivative, plus 1 there, okay? Plus 1 is 1 half, so 2 times h is what? 1 half. It's okay?
Yeah.
And the right hand side, okay? We cannot put the only constant in the one side, not both sides, okay? That is equals how much? Negative 1 over 10 times t and plus c, isn't it?
Yeah.
Okay, so we're going to express h over here, right? In terms of t. They asking you express h. H equals. So we got the h there. You can divide it by 2, right? First, we can divide it by 2. When you divide it by 2, h1/2, that's what? Square root h is actually equals what is that? Negative 1 over 20 t, and the plus c over 2 still constant, right? C over 2 still, we can use a constant. It doesn't matter, okay? After that, you make a square again. So h is how much? Negative 1 over 2t and plus c squared, right? Are you okay with this? Okay, now let's find the value of c at this moment, okay? The initial is when time t is 0, h is 5. H is 5, t is 0. This is 1 over 20 times 0 is 0 plus c squared, okay? Okay. So we have two values of c. C equals how much? Plus minus?
Plus minus.
Square root 5. But which one is correct? Plus minus square root 5. Which one is correct? We have two numbers over here, okay? A little, this is a little, we have to careful, okay? This is plus minus, okay, also, this is also plus minus 5. Okay? But this is square root h is a positive, isn't it? At times, okay? At times t equals 0, c should be positive, right? It can be negative, so this one should be positive only. It's okay? When t equals 0, take root. 0 equals what? This is positive equals positive, right? Okay? Yeah. So this one cannot have a negative number, okay? So only positive, okay? So finally now h equals how much? Negative 1 over 20t and plus square root 5. Okay? That is h over t. That's the solution, okay? So how to think? It's okay, you can you think you can do that, this one? Okay. That is number 4, okay? Now go to number 5 there. Okay. Number 5, a little looks like a simple, but you're gonna be careful, okay? Need a little careful. Okay, R is the region enclosed by g of x, negative 2 plus. Okay, h over here, negative 2 plus 3 cosine pi over 2x. Which one is g of x? We have two graphs over here and here. Okay, how can you find this one? Put this number x equals 0, you can find the y-intercept over here, right? So which one is the top, which one is the top bottom over here, okay? When x equals 0 over here, oh, you can use the cosine 0 over here. Cosine 0 is 1, right? Negative 2 and the plus 3 is 1, okay? So this is 1 is what? This one, g of x graph. This is h of x graph is the top, okay? And with this y equals h of x, y equals g of x graph. The area of this one, top minus bottom, okay? So until from here, we have right 0 to 2. The distance, top minus bottom, okay? So you can use h of x minus, I'll do this one more times, h of minus g of x. We take this one, integral 0 to 2. It's okay? All right. Okay, we're going to this one. 0 to 2. H of x is this one. 6 minus 2 x minus 1 squared. And minus g of x is what? Negative 2 plus 3 cosine pi over 2x dx. Okay. Okay, now a little simplified, that is better. 6 minus minus 2 is 8. So you got this 8 minus 2 x minus 1 squared, right? After that, minus minus plus is minus again 3 cosine pi over 2x. not dx. Okay, now find out this antiderivative, okay? Oh, this is a lot of work too. 8 is what? 8x, antiderivative, 8x. 2 minus x minus 1, this one same as this one, okay? x1 and x minus cube, that any constant, it's going to be same thing. What is the antiderivative this one? Plus 1 and divided by 4, right? x2 over 4. This one also what? X minus 1 to the over 4, same thing, okay? X minus any constant, it follows what? This parent function, okay? So minus. Divided by 3, 2 over 3, right? We got the 2 there. 2 over 3, x minus 1 to the cube, okay? And the third one, antiderivative. Sine derivative is a cosine, okay? So antiderivative is what? Minus 3 sine pi over 2x, okay? But this is pi over t is what? Chain rule, okay? So we have to divide by pi over 2 again. That is what? Pi over 2. It's okay? Right, now simplify this one. Okay, I'm going to 8x minus 2 over 3 x minus 1 cube. 3 divided pi over 2 equals negative 6 over pi and sine pi over 2x, okay? That's the antiderivative. We take integral from 0 to 2, okay? This is a lot of work, okay? Yeah, many times we take antiderivatives. Put this number 2 there, that is 16. Minus 2 there. 2 minus 1 is squared, that's 1, just leave right this 2/3. Now, this is 2 there. Sine pi is 2 times 2 over here, 2 is cancelled. The sine pi is already 0, right? So it's nothing. Now, put this number 0 there. This is 0. Second one is 0. Minus 1 cube is still negative 1, right? 0 minus 1 is negative 1 cube is negative 1. Another negative is plus positive 2/3. Sine 0 is about 0, okay? That's fine. So 16 minus 2/3 minus another 2/3. 16 minus 4 over 3. 16 is about 48 over 3 minus 4 over 3, right? It's going to be 44 over 3, okay? This is the area of this region R, okay? Well, this is a little more work over here, okay? All right, number B there. The region R is the base of solid for the solid at each x, the cross section perpendicular to the x-axis. This is the x-axis, this way, okay? Perpendicular. Okay? But this time it's okay. It's the area is given over here, okay? When x over here, this anyway, I don't know why, what type of right figure. This area equals what? When x equals a there, 1 over x plus 3. That's the area, okay? We already got the area of this one. But this is simple then. So what is the volume of the solid? Okay, this is what kind of length. We're gonna build some construct, okay? Some buildings on this length. It's okay? So area is given over here. So take all this area from 0 to 2, ax dx. Okay? That's the volume. So 0 to 2, ax dx is 1 over x plus 3. Okay? That is dx. 1 over x any minus x plus y constant. That is what? ln, natural ln. Okay? That is why ln epsilon value x plus 3. That is antiderivative. We take integral from 0 to 2.
Yeah.
Okay? Now put this number 2 there. ln 2 plus 3 is what? Positive. We don't need the epsilon value, okay? Just ln 5. Minus ln, when x equals 0, ln 3. Epsilon value 3 is still ln 3, okay? You can use this way. ln 5 minus ln 3 or ln 5 over 3, okay? That's that, okay? That's the volume. The next one over here, the right, this time it's okay to not evaluate the integral expressions that gives the volume of solid generate, okay, when R is rotated about horizontal line y equals 6. I'm going to type that. Where is y equals 6? 1, 2, 3, 4, 5, 6. Oh, okay.
Yeah.
This one is rotation axis. Rotate over here, okay? So when you rotate over here, this one is, what is that? Largest hole, right?
Yeah. You can.
The larger hole when you make a rotation over up to here.
Okay.
This one actually the largest hole, okay? This one is what? The radius of this large circle, okay? I'm gonna this one is over here, intersection of it. I'm gonna take a little different, okay? If this is all up. Sorry about this. At this moment, okay, there's no empty space, okay? So I'm gonna use this one. It's okay?
Yeah.
When you make the rotate about this x-axis, looks like this. Here, same things. Looks like graph of this one. Yeah, this is R, right?
Yeah.
Roger, right, forget this R. But there is empty space over here, empty space over here. A little empty space. This R equal how much? Little r. Are you okay with this?
Yeah.
Okay, look like this one. This. When you make this one. Come on. Of course, over here, a little empty circle there, okay? All right. So this is empty. We're gonna find this area, right? And this is R. From here, R. This one is what? Little r, okay? So what is the area of this one? Pi r square and minus r square, isn't it? Is it okay? We take integral from 0 to 2, that's it, okay? All right. So 0 to 2 integral pi r square, okay? Pi. This r is how much? This r is how much? 6. This is 6, right? 6 minus bottom of it, right? That's the bottom is what? Bottom is g of x. So 6 minus g of x. Okay? But we need r square, right?
Yeah.
Square. And we take up a little r squared, this one, okay? Area of this one. We are 6 minus top of here, okay? So 6 minus top is how much? H of x, right?
Yeah.
This is a 6. This is h of x. The length is about 6 minus h of x, this length, okay? 6 minus h of x and square, right? That's a pi r squared, okay? Pi is out. So that is a dx. It's okay? This is the what? The volume of this rotated right figure, okay?
Yeah.
Actually, we don't need a calculator. It's just to show this is okay. But in this case, you can replace with why g of x is over here, okay? But you don't have to. It's already, because we don't have to evaluate. To evaluate, you can put this number over here, right?
Yeah.
But actually, this is, we don't have to evaluate. You can leave right g of x and h of x. That's fine. You'll get the right full credit anyway, okay? You don't have to write replace with negative 2 plus 3 cosine pi over 2x in here, right?
Yeah.
Okay, you don't have to. Okay, just leave it this way. Okay? They don't care about what substitute in the gx of h of x, okay? All right, that is the number 5, okay? So how to think of number 5? It's okay?
Yeah, it's making sense.
Right, okay. Yeah, that is the last questions with non-calculator sections. Take a look over here. F, G, and H twice differentiable. G over 2, H over 2 is 4. Okay, and another y there. What is this? This is the equation of tangent, right? This is the equation of tangent to this graph. Okay, both graph. So it looks like this one. The graph of g of, for example, so roughly we can say if this is y equals g of x, this is y equals h of x. Yeah, both have a tangent over here, right? They are tangent each other, so each tangent line both two must be what? Same tangent line, okay? This line is y equals 4 plus 2 over 3 x minus 2. It's okay?
Yeah.
Looks like this one, okay? Because they have the same numbers. When x is 2 over there, they are both at 4 here, right? This point is 2 and 4, okay? Roughly, we simply, it doesn't have to always this way, okay? But roughly, we can guess this graph. So now let's find f prime 2, h prime 2. What is h prime 2? H prime 2 is what? H graph. This is H graph. H prime 2 is what? Derivative at x equal to, which is what? Slope of this line tangent. That's when you find what? H prime, not F. Okay. H prime equals what is that? Slope of tangent line. Okay, slope of tangent. Where is slope of tangent? We already got slope of tangent over here. 2/3 is what? Slope of tangent, right? That is equals 2/3, isn't it?
Yeah.
Okay, so h over 2 is exactly equals to 2 over 3, okay? Because what? The tangent line is given already. Y equals 2/3 over x and minus negative 4 over 3 and plus 4, right? Yeah, this is the slope anyway, right? All right, the next one, number B. Let A is the function, AX is a new function over here. AX is a new function, so I'm going to write down over here. Write the express A prime X and find out its derivative at X equal 2, right? That just create new functions. But it doesn't matter, okay? A prime X is how much? That's when you find A prime. Take A prime X. And we have two functions over there, okay? So we apply product rule, right? First derivative times second one. First derivative is what is that? 9x squared times second one. Don't touch the first one. Take a second derivative is what is that? H prime x, isn't it? It's okay? Okay, put this number in there, okay? When x is 2. So A prime 2 is how much? This is the answer, okay? First one. Are you okay with this? What is H prime x? What is H prime x? We still don't know, right? That's still not specified, okay? H prime x can be any numbers. It's okay? That is what derivative functions, okay? But you can leave it this way. The next one is what? We're going to find, okay, derivative at x equal 2. Now that's going to be cleared, okay? We're going to evaluate the h prime 2. So this is, put the number 2 there. 2 times 2 squared is 36. And h2. Plus 3 times 2 cubed is 8. That is 24. H prime 2, isn't it?
Yes.
Now can you find h over 2? When x is 2, h, this one still 4 over there, right? Okay? So this one is actually equals to what? 36 times 4, right? 144. Because the h2 equals to 4 there, okay? And h prime t, Where is h prime? We already got over here. H prime here, over here. Slope of tangent at this x is 2, right? 2/3. So plus 24 times 2/3, right? So this one is exactly equals to 16. So 144 plus 16 equals to 160 is the answer, okay? So this answer and the other answer. I think number A, B, is okay, right?
Yeah.
Yeah, that is not hard, I think. All right, try number C there. Try number C. The function h are satisfied this way. Okay, the relation between f of x, okay? But f of x is we don't know still, okay? Right, f of x we don't know. Some f of x there, we guess. So h of x is related this way. Okay, so it is known that the idea is what? When limit value x close to h, okay? So I'm going to write down, okay? Limit h close to h of x, okay, equals to limit x close to h of x defined this way, okay, using some unknown function f of x, okay, x squared minus 4 over 1 minus f of x cube, right? Is it okay? So this one can be, this limit can be evaluated using a L'Hopital's rule. It can be we apply to applying L'Hopital's rule. Okay, then we can get what limit value. Are you okay with this? Okay. To apply L'Hopital's rule, there's a condition over here, okay? Put this number 2 there. First check it out. To apply L'Hopital's rule, it can be 0 or 0 or plus or minus infinite or plus or minus infinite only, okay? Put this number 2 there. Check it out. Test. 2 squared minus is 4 minus 4 is 0. We got the 0 over here. To apply L'Hopital's rule, denominator should be also 0, right? Are you okay with this? To apply the L'Hopital's rule, okay? So only 0 over 0 available at this time. How about that? It is understandable? Are you there?
Yeah.
It is understandable, this one?
Yeah, it's making
To
sense.
apply right here, L'Hopital's rule, because when you check it out, okay, numerator is already what? 2 squared minus 4 is 0, right? So to apply, in order to apply L'Hopital's rule, denominator also should be 0. Okay, so it should be 0. This system f of x must be what is that? Over here we can say f of x should be equals to 1, is it? Are you okay with this? When x close to 0, right? Should be equals to 1 there. Okay, now let's find f of 2, okay? Okay, so we know that f of x, I'll put this number, I'm gonna put this number over here. When x close to, put this number x close to over here, this one should be equals to 1, right? 1 minus 1 equals 0, okay? So f of 2 must be equals to 1 there, okay? Okay, this one equals to f of 2, 1 minus, this is the cube, must be 0. So this one also equals to 1, okay? So f of 2 must be equals to 1 over here. So f of prime 2 is 1 there. Are you okay with this? That's the first one. Second one is we take right integral now. Okay. Uh, this is a little bit hard for you. Okay, anyway, we apply right f prime to get this one, we take right integral, right, using L'Hopital's rule, okay? So I'm gonna, this one you're gonna do next time, okay? This one. Limit f close to limit x to square minus 4 over 1 minus f of x cube. You apply L'Hopital's rule, take derivative of your 2x. Still there's a limit, okay? Denominator, what is that? 1 minus 3 times f of x is what? Square, right? And times inside we multiply f prime x, isn't it? Now put this number 2 there. Numerator is not anymore 0, okay? So this is a 4 here. Put this number 1 minus 3. Inside the f of 2 square and the f of prime over 2. Are you okay with this?
No.
Right.
No.
So f over 2 is how much? F over 2, you already got 1 there, okay? No, that is 1, okay?
Oh, wait, never mind, yeah, sorry.
So this is what? 4 over 1 minus 3 times f prime 2, isn't it?
Mm-hmm.
Okay. So what is the value of this one?
-2, I mean...
what is the, okay, using L'Hopital's rule, what is the, this is for?
Derivative of top is 0, so 0. 0 over 0.
The top is not 0 anymore.
The derivative, once you take a derivative?
Yeah, we took a derivative already.
Oh, okay, never mind. I see it now.
Okay.
So we got this as the derivative.
Yep. So what is this value here? Limit value.
Mm-hmm. We can plug in something for the f of x part. So it'd be 3 times the f prime, the derivative of f of x, which you found is 0 is we found in the previous one.
Okay, this one okay, we'll continue this one next time. Okay, we need a little more expression, okay? C and D, okay? Yeah. Definitely you can try A and B, okay? Also you can try C and D because you can get there is answering the answer key is released, I think, okay, on your college board. You can take a look. But anyway, we're gonna try these two questions next time, okay? Yeah, I don't have a time right now, okay? All right.
Okay.
Okay, I'm gonna send out the link to you. Okay, that's all today, okay?
Okay. Thank you.
You have a good night, okay? Bye.
Have a good night. Bye.